Hi everybody, it's Mr. Defy once again, and welcome back to another video by me. This time I'll be showing you how to create a slope-intercept form, specifically how to create this using 2 points that are known to be on the line of the function. And there are a couple of ways that I want to show this to you, so I set up 3 examples. First, I want to quickly remind you that slope-intercept form is y equals mx plus b. I did create an alternate version of that, which really means the same thing. It just looks different at the beginning. F of x equals mx plus b is the same thing. Whoops, I erased my plus sign. The same thing as saying y equals mx plus b. So this y and this f of x really are the same thing. They both have to do with outputs. Okay. So let's take a look at example 1. Example 1 says, a line passes through points m, which is at 3, negative 6, and k, which is at 0, 10. What is the name of this function? Well, we don't have a graph to look at, and we don't need one, to be honest. But this question is kind of like saying, if you're in a room of people, and you say, I'm thinking of someone who has a long sleeve shirt and is wearing jeans. Well, there might be many people who fit that description. So unless you give a little more direction to your clues, naming the individual you have in mind might be a little difficult. So this is kind of like that. You have a little information about the function. You're trying to discover what the name of the function actually is. And the way to do it is by remembering that in this function, y equals mx plus b, the b represents a place of beginning, which represents an ordered pair, 0, whatever b is. And m represents movement along the line, up or down, and that's always represented as a change in y over change in x. So what you want to do is you want to look at your ordered pairs, and you want to see which ordered pair best fits the description for where to begin. Again, look carefully at that. That's always going to be 0 and then your output number. And so if I look at my first order pair, I see, well, that does not look like 0, a number for b. So I'm going to move on. If you look at order pair k, you can see that does fit the description for what the y-intercept should be. It's 0, and then a number. So what I will do is take this number 10 and place it right into that location of the function. So the 10 will take the place of the letter b. And what I get when I do that, what I get is this. I get y is equal to mx, because I still don't know what my slope is, and then the number 10. Now this 10 will be either a positive or negative, depending on what you're given. Now, if you look here, the 10 is clearly a positive. So I need to put the sign that represents this idea. Therefore, I put a plus sign. So now it's y equals mx plus 10. Okay, so now I need to get my slope. Well, there are a couple ways to do this. And I want to set up the order pairs here at the side so that I can make a point here about this. So we have 0, 10. And we also have 3, negative 6. And I'm going to set them up twice, and I'll show you why in just a moment. 3, negative 6. The reason I'm setting this up twice is because you need to choose a direction to move in. Now what I mean by that is you can either go from 10 to negative 6, or you can go from negative 6 to 10. It really doesn't matter because these 2 points are on the same line anyway, but you have to pick one. Now, if you choose to go from 10 to negative 6, then your direction from the input side must be the same. So it has to go from 0 to 3. Likewise, if you go from negative 6 to 10, your direction for the inputs must go from 3 to 0. And what this means in terms of getting the slope is the following. When you do the change in y over change in x, the setup depends on the direction that you choose to go. So if I choose to go from 10 to negative 6, then I need to write it the way I say it. So I'm going from 10, changing into a negative 6. And for the changes in x, it's the same thing. You're going from a 0 changing into a 3. So what that gives you is a 10 plus 6 over a negative 3, which is like saying 16 over negative 3. Okay, and that would be my slope, 16 over negative 3. You don't need to make that a decimal or a mixed number, just leave it like that. For the other one though, the change in y over the change in x. The change in y this time, because I'm starting at negative 6 and going to a 10, I write it like I say it. So I start with negative 6, changing into a 10. With the denominator, it would be starting at 3, changing into a 0. And so in my numerator, I get negative 16. In my denominator, I get 3. And as you can see, my result is exactly the same thing. Okay, and they are supposed to be the same. It shouldn't matter. It shouldn't matter which direction you take. What should matter is the math that you do. When you have to be careful in the way you subtract, and that's why these double negatives can be a bit tricky sometimes. You have to remember that those two become a plus sign. Okay, so now that I have my slope, I will go back to my function, and I will replace my m with what I just got, which is negative 16 over 3. And so this is what I have. I have y equals negative 16 over 3, x plus 10, and with that, my answer is completed. So this is a function that creates a line that goes through these 2 points, m and k. Okay? So that's example 1. Example 2 actually has a picture. So it has a picture, but the question is still the same thing. What is the name of this line? The function of the line. And to answer that question, you want to extract information from this line. Namely, you need 2 points. One, you want to see if this line clearly crosses the y-axis. The y-axis, again, is this line going straight up and down, vertically. And you also want to choose a point that is cutting right through the corner of a square. Those 2 points will help you to figure out the slope of the line. Okay, so if I look carefully, I can see that this red line cuts through the y-axis right there at negative 2. So I'm going to go ahead and put an ordered pair. This is 0, negative 2. Okay, notice again that my first number in that ordered pair is a 0. That always indicates a y-intercept. So what I can do right away is I can begin to build my function. My function, once again, is y equals mx plus b. And I know from this graph that my beginning number, my y-intercept, is a negative 2. So far I have y equals mx minus 2. Now to get my slope, I can either do it by counting the squares, or I could do it by picking 2 points and calculating the change in y over change in x. I'll do both so that you can see how each works. So by counting squares, you still need to have a second point marked. So I'll choose the next one up, which is right there. And counting from my y-intercept to my second point, you have to go up 1, so it's 1 up. That's a positive 1. And then you simply go 1, 2 to the right. Now, because you're going to the right twice, right? Because you're going to the right, that's a positive direction. My slope, therefore, is positive 2 over 1. So my slope is positive 2 over 1, which when you divide that is just 2. So I can go into my function, replace the m with my 2, and now I get y equals 2x minus 2. And with that, my function is completed. But I wanted to show you how to calculate the slope and get the same thing anyway. So my second point would need to have its own ordered pair. This is at 2, negative 1. So if I use the change in y over change in x, again, you have to choose the direction you want to move in. I'm going to go up the line, so I will start at my y-intercept, and that means that I start with negative 2, and it changes into a negative 1. But my x's start with 0, and then change into a positive 2. There's that double negative again, so remember what happens. It becomes a plus sign, and we get negative 2 plus 1. Here we get negative 2. This is negative, I think I did something wrong here. Let me see. -2, -1. Yeah, I think I'm going to go back. I'm going to go back and, yeah, I think I know what I did. Sorry about that. I know exactly what happened here. I need to change my slope over there. But, so you get a +1 over a -1, excuse me, over -2, which when you divide it, you get 1 over 2. So just to clear up that little mishap earlier, you go up 1 and right 2. I wrote the slope incorrectly in the function, so this actually had to be 1 over 2. Sorry about that. So it's a good thing that I checked my work by actually calculating it. That way I knew, hey, I wrote this initially was y equals 2x minus 2, and then I realized, well, wait a second, my slope actually came out to +1/2. There's no way that this could be a y equals 2x. So then I went back and changed that. So I'm sorry about that mistake, but that's why checking your work is always a good thing. So there you have it. This is example 2. Now in example 3, it's asking what is a function of a line that passes through these 2 points. Now right away you should note that when you look at this function, there is no point that gives you the y-intercept right away. So what that means is that it needs to be calculated. And if you don't know the y-intercept immediately, you go for the slope. So first I'm going to get the slope. Change in y over the change in x. So again, pick a direction to go in. I'll start with -11 and change that into a 7. And then that means I start with -2, which changes into a 4. The -11 minus 7 is -18, and the -2 minus 4 is -6, which then becomes a +3. So now I know my slope is a 3. So I will go into the function and write y equals 3x plus b. Now to get my b value, I need to choose one of my ordered pairs, either this one or this one. And I recommend choosing the easier of the two just so that you can get it done. And so 4,7 looks easier when I don't have to think about negatives and the rules for that. So I'm going to use 4,7 to get my b. And this is the way it goes. You take the x and y value from each and you drop it into the function as you have it right now. So what I have is 7 is equal to 3, which is my slope, multiplied by my x value from my ordered pair, which is 4, and then plus b. Now you solve it because b is the only variable you have now to think about. And what you have is 7 is equal to 12 plus b. Subtracting 12 on both sides, you get -5 is equal to b. And that is my y-intercept. And so what you do with it is you take that y-intercept and you replace the b with the -5 and you finish it up. So therefore, what I have is y is equal to my slope, which is 3, so it's y equals 3x, and then my y-intercept, which is -5. So my function is y equals 3x minus 5. And I hope this video helped you. Please feel free to go back and replay it as often as you need to. I realized that at the end I made a slight blunder in my second example, and I do apologize for that, but I'm glad that we were able to fix it and move on. So if you have any questions or comments, please feel free to post it either on YouTube or on Schoology, and I hope to see you again soon. Take care. Bye-bye.